Here's a little insight on what's really going on when we passed a pointer into a function. The point about pointers isn't that they have a special ticket that they get to sneak around the problem of scope. Pointers, just like any other variable, also has the rules of scope. Meaning like this, just like over here when I pass in the variable var into the increment function, when I go over there in the program, over here in this function I won't have the actual variable that we passed in, I will only have a local copy of that variable, as we learned in a different video. The same thing will happen when I pass a pointer. When I pass this pointer object which I created before, when I pass that into this function increment p, what happens in that function over there is that a local copy of the pointer is created. And the pointer ptr in this function over here is a completely different pointer than pointer 1 in our function. So if you're not totally confused yet, you understand that pointers also have the limitations of scope. However, here's the difference. Just as when I pass this variable into this function increment, when the program makes a local copy, it will copy the correct value into the local copy over here. So whatever var had in this function, which at this point I think was 0, the local variable over here will have the same thing. So the local x will also have 0. So when I say local copy, I mean it, a copy, a perfect copy of the variable. Whatever the variable had in this scope, this variable over here will have that same value. The same thing is true about pointers. When I pass this pointer into some other function, just like this pointer over here had a certain number of an address in memory, something like who knows what, 0022F4A, this very same number, this very same address in memory will be perfectly copied over to the local pointer in this function, which means like this. Just like in this function over here, when I had this pointer, I could access that pointer and access the variable which is pointed to with the pointer, and I could do whatever I want with that memory location. The same is true with this function over here, to which I passed the pointer. Because it contains the very same memory address which I passed to it, and that memory address, whatever it is, 0022, whatever it was, right now this function has as much power over that variable as the main function had over here. So just like over here we could do whatever we want with that variable, over here too this function could do whatever it wants with that variable because it has the memory location where it is stored. And with the memory location we have all the power. And so you can go ahead and just by getting the address of a certain variable, you can pass around a pointer to that address from one function to another function, from one scope to another scope, and anyone who has a pointer to that very same address, to that very specific address where this variable is stored, will have full control over that variable and would be able to do whatever it wants with it, change it, check what's inside of it, etc., etc., whatever you could do with a regular variable just by dereferencing the pointer that we have, just like we do over here by dereferencing this pointer. And for that matter, let me show you a neat little trick. What we did over here, if you remember from last video, is first we created a pointer and we gave it the address of the variable, and then we passed the pointer into the function. However, the truth is we could do this all perfectly without the need of creating a variable, of an actual pointer. Here's a little shortcut of how you can do it. Instead of making a pointer which you pass into the function, try passing in right away just the address of the variable into a function which awaits a pointer. Again, instead of creating a variable and then making a pointer which will point to the address of that variable, and you will pass that pointer object into the function which awaits a pointer, instead just create your variable, don't create no pointers, then just pass in the address using the ampersand symbol of your variable straight into the function which awaits a pointer. And guess what? Your program will work perfectly as expected. just as if you would have passed in an actual pointer. The magic over here is that C++ recognizes the address of a variable as a pointer type, because only pointers can hold addresses of variables. Nothing else can hold an address. So in the concept of parameters and expressions, a variable name gives off an expression of the variable type. A variable address doesn't give out an expression of the variable type, but rather gives off an expression of a pointer to this variable type, because the address of a variable can only be put inside of a pointer. So in short, this right over here is as if I would have had a pointer which I am passing inside of this function, because the address of a variable is recognized as a pointer, or more precisely as a pointer type. So that's an interesting little shortcut right there. Instead of making a whole pointer and then passing that pointer, just pass the address of a variable, and that will automatically be okay for a function which awaits a pointer. So that's it. Now you know about pointers. I'd suggest you take a break right now and start playing around with pointers, testing out everything you can do. Make a function that returns a pointer. Make a pointer which points to another pointer. Try to dereference that pointer to pointer. Create a custom class of your own with pointers inside of it, and then make a pointer which points to your class type. Then create some objects of your class type and make pointers to them. Pass the addresses of these instances of your types in and out of functions. Go ahead and play around with it until you're completely comfortable with the exact way how pointers work, because this is a very essential basic part of C++ to understand the functionality of pointers. And we will be using them very often throughout any program that you make in C++. Let me show you something interesting about C++ arrays. If you remember, we learned how to create an array of whatever type of variables you'd like by using these square brackets and defining exactly how many elements you'd like to have in the array. What really happens over here behind the scene when you create an array is that the program will prepare this number. If it's 20, then it will prepare 20 times as many bytes needed for the type of variable that this array has. In this case right over here, because in my compiler a integer uses up 4 bytes of memory, so right over here in our program, this array will prepare 80 bytes of memory in RAM. Then what happens is the name of our array acts pretty much like a pointer, and as a matter of fact, it is a pointer which points to the very first element, to the address of the very first byte of our array. Now in your code, whenever you will try to access a certain element of this array, like for example right over here we're trying to access the 4th element of the array by typing array3 inside of the square brackets, what happens is we are telling the pointer to start at the very first location where it's pointing to, which is the very first byte, and step forward 4 steps, well actually 3 steps, until it reaches the 4th element, which begins the first byte of the 4th integer. And so now this over here will be like a pointer to the variable which is stored in memory at that particular location in the 80 bytes. So basically in C++, arrays use the functionality of pointers to handle one big chunk of memory that has in it a whole bunch of whatever type you'd like, integer or char or whatever you'd like. And as we will learn pretty soon, that is also the danger of using arrays and pointers in general, that when you try to go out of bounds, as I explained in the video about arrays, what happens is your pointer will try to read a piece of memory to which he doesn't have access rights, as we will see in a future video.